We're talking about the line of best fit, the best line of best fit, or is it? So basically we're analyzing lines of best fit. And one of the things that we talked about that I'd like to look a little bit further on is what is considered a good versus bad residual plot. So forgive the random ads because this is a website. Do the residuals exhibit a clear pattern? So in a good residual plot, the residuals exhibit no clear pattern. In a bad residual plot, the residuals exhibit some type of pattern, such as a curve or a wave. This is an indication that the model we used does not provide an appropriate fit. And that makes sense. And if it doesn't make sense, then I'm going to show you some examples here in a second. Let's scroll down a little bit more. Do the residuals increase or decrease in variance in a systematic way? So what's that mean? Well, in a good residual plot, the residuals are randomly scattered about the zero. There's no systematic increase or decrease in variance. In a bad residual plot, the variance of the residuals increase or decrease in a systematic way. Again, if you're like, what does that mean? Let's just keep going. So here's an example of a good residual plot. So what does good mean? Well, the idea is that if we were on zero, if all these dots were on zero, then they would be perfectly on the line of best fit. But because this one's good, what they're trying to say is these are just like randomly off the line. Like this is 4 and 2 and 3 and 2 and 1 and 1 and 3 and 2 and 3. You get the idea. So let me scroll down the line. This drawing might move around with the graph or with the website, so don't fall in love with it just yet. Do the residuals exhibit a clear pattern? No. They're randomly scattered about the zero with no clear pattern. So that's one reason why we call it good. And then the other reason is, do they increase or decrease in a systematic way? And the answer is no. They have a fairly consistent variance, which what they mean is the distance between the residuals and zero. Like if they were all going up in a line, okay, well that would be increasing in a systematic way. If there was a curve, that would be a systematic way, right? So let's check out a bad one and where there'll be a clear pattern. I mean, it's very clear right away. Yeah, there's zero, and then here's like the pattern is, oh, it's this far away, this far away, this far away. Boop, 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 boop. You can see that there is like this curvature, right? So that is going to be a bad line of best fit. Let's scroll down again, just see kind of what they say about it. So do the residuals exhibit a clear pattern? And yes, there's clearly a curve. Do the residuals increase or decrease in a systematic way? Yes. The residuals have different values of variance at different levels of fitted values. So since we said yes, this thing stinks. Are there any other examples here? Okay, here's another bad one. Suppose we fit a model on this one. So let's see, why is this one bad? Well, there's zero. And then here's my thought is these kind of go up and away, and these kind of go down and away. So let's scroll and see what the website has to say. Look at all these ads. It's crazy. Sorry. So do the residuals exhibit a clear pattern? No, there is no clear pattern. And then 2, do the residuals increase or decrease in a systematic way? Yes, which is what I said. The green line seems to go up, the yellow seems to go down. And since we answered yes to at least one of these questions, we consider it to be a bad residual plot. And then here's a fun Jeopardy word. In this particular example, the residuals suffer from heteroscedasticity. I'm not sure that's how you say that, but that refers to unequal variance. And if you're like, what the heck is variance? Basically think of it like varying, right? Anyway, so this hopefully explains a little bit about it. If it doesn't, then my bad. I'll do what I can to try and explain it. Just think this one's good, because there's no clear pattern, okay? And it's also good because there's no increase or decrease in a systematic way. This one's bad because there's clearly a pattern and there is a systematic increase or decrease. This one is bad because while there is no clear pattern, like a curve, there is definitely a systematic increase or decrease. In fact, it had both. Okay? Okay.